This video is on Lesson 1 from the Grade 8 Module 2 book found on page 1. So, we are just getting into something called geometry in this one, dealing with shapes and different things we do with shapes. We are going to start off by talking about 3 types of transformations. And we see that word right here in the paragraph we're given. So, our exploratory challenge, it says describe intuitively what type of transformation is required to move the figure on the left to each of the figures 1 through 3 on the right. We don't have a transparency sheet to use in this, so we are just kind of going to observe what happens with this shape and how we can turn this shape to look like these 3 other shapes, noticing how they all look similar to each other. So to get started, let's organize our paper a little bit. I want you to break it up. Well, not break it up, but make sure you have space to write 3 definitions, like so. And these numbers are going to match up with what we have to do to turn this shape into this shape. So let's go ahead and let's get into it. First thing I will do is make sure I'm able to move this shape, which I am able to. We'll zoom back in. So let's talk about first how to go from this figure right here to this figure. Now, this one's kind of simple, maybe a little too simple. If you notice, it was here. All we have to do is slide it up here, and it takes the same shape. Now, my mouse is being a little funny. It won't let me slide things too smoothly, but we can see how all I'm doing is sliding from here to here. So our first type of transformation, we should actually throw that title in at the top. So go ahead, throw that in there, types of transformations. Our first type of transformation is a translation, which another word for that, maybe easier word to remember, is slide. So a translation moves an object from one position to another without changing how the object looked. And again, we can see this, our original, and the position number 1 pretty much look the same, just in a different spot on the paper. All right, so translation, pretty simple. Let's go on to number 2. So number 2, we see how the red rectangular portion is now on the top part of the circle. In order to make that happen, we needed to flip the object. I'll go ahead and flip, and we see how now that matches up with what we had. We would flip. Now, technically, my computer didn't do it for me, but when you flip something, it actually changes where it is on the paper also. So keep that in mind, but we see that flipping the object makes it look the same. So our second, the official type of transformation, the official name for it is a reflection, which you can think of as a flip. The official definition for a reflection is that it turns the object over an invisible line, and that line might be vertical, horizontal, and there's other types that we'll talk about later on. Do not include this scratch out thing here. My computer had somewhat of a breakdown, so we're going to ignore that. All right, so we covered how to get to 1. We covered how to get to 2. Now we got to look at how to get to 3. So I'm going to turn the object back into what it was. There we go. Now it looks just like the original. So our last transformation, take a look at this. Our last transformation is going to be where we spin, or the official word is rotate the object. So when you rotate, there's different directions you can rotate it. As you can see, I'm having to click a few times on rotating. But eventually, after I rotate, think of rotation as spinning the object. Here's another look at it. This program lets me actually rotate it a little better. So I see our original object. I can take this, and if I spin it, there we go. You guys can see how how I'm able to rotate it to look just like how position 3 is. So the third type of transformation is a rotation, which, easy word to remember, is a spin. The official definition of rotation is that a rotation turns the object around a point. So I want to point that out. Reflection turns it over, so you're flipping it over a line. Reflection turns it around, so you're just spinning it. And when we say turns, there's two types of turns you can make. There's clockwise, where you take it and you spin it just like a clock would, or counterclockwise, where you would go the opposite direction and you spin it that way. All right, there are our three types of rotations. Let's take a look at part B, where we're given two segments, A, B, and C, D, which could be very far apart. How can we find out if they have the same length without measuring them individually? Do you think they have the same length? How do you check? In other words, why do you think we need to move things around on the plane? So to do this one, what I did is I actually took a picture of this and I put it on this other program. I took a little screenshot here. I took a copy of AB, and you guys can see here. So here is AB. First thing I would do is slide it, which means translate it upward. And when I translate it, you guys can see how it is the exact same length. Maybe I just have to position it a little better. There we go, exact same length. A is in the same spot, B is in the same spot. So the distance is preserved when I do that. Then, if I want to get it to compare it to CD, because I'm trying to figure out if they have the same length, well, I know I'm going to have to slide it a little bit. And right there, it's not too easy to compare yet, but I can then rotate it, slide it a little more, and we can see I can't get it too close, but right there, we can see how they are pretty much the same length. Now, I might have to slide it up a little bit more. There we go. We can see how they end in the same spot. So back to our paper. Down here, we'll answer the question, do you think they are the same length? We'll say, after translating and rotating, again, that means sliding and spinning, we see that the ends of AB and CD are the same distance apart. So, translating, rotating, and reflecting does not change the size of an object. We did translating and rotating. We didn't do reflecting. I can do reflecting real quick. Just to prove it to you right here, if I select flip, which we know means reflect, I'm going to flip it vertically. We see how it flipped it, but it did not change the length. I can keep flipping it back and forth, and it does not change the length of that line. So all three of those transformations preserve the size of the object.